So we have a wooden block. We're told the volume of it. So small block. It's floating in water, and we're told that 75% of it is submerged, meaning that 75% of it is below the surface. And we're asked for the mass of the block. Okay, so the block feels two forces. Gravity pushes downwards on it, and then the water pushes upwards on it, and we call this the buoyancy force. So if these two things are balanced, it will float. So on the one hand, the gravitational force you could express as, I'll do it in steps, as the mass times the acceleration due to gravity. The buoyancy force is the mass of the displaced water times the gravitational force. So the mass of the object I could express as its density times its volume. So the mass of the water that's displaced, here I have to be careful. So this is going to be equal to the density of the fluid. So let me call this block. Let me call this water. And then this V is going to be the part of the volume of the water that is displaced by the block, right? So this is going to be submerged. So I get that the part of the block that's submerged divided by its total volume is equal to the density of the block divided by the density of the water. Right, so we're told 75% of it is below the surface. That means that the block's density has to be 75% of water. So if water is 1,000 kilogram per meter cubed, the block has a density that is 75% of that, or 750 kilogram per meter cubed. So just to get the mass, the final step would be that the mass of the block is equal to its density times its volume, or in other words, 0.02 times 750. So that would be 750 divided by 50, which would be 15 kilograms.